So I feel like number one's like the general. When I think of factoring, I think of a quadratic trinomial, and my steps are find the factors of the first term. So it's 12x times x, or 6x times 2x, or 4x times 3x. So we have a few options. And for 15, it's either 1 and 15 or 3 and 5. You're not always going to guess it right the first time. So if you're a person that, you get mad, or it's fine, and still to this day, I've been factoring forever, and I don't always just magically guess right the first time. I do have some things that usually cut down on my work. So I like to write my pairs out in order, and I work backwards off of those pairs. It just, a lot of the time, it saves you work. It's just kind of a magical thing that happens. And then another thing, like let's say I start with 4x and 3x. If you've done it, you know that that's not going to be the correct thing, and I know that. But I just wanted to show you a few things. If I'm plugging in 3 and 5, you cannot put common factors together. So I cannot put a 3 with a 3x. So once again, that just saves you a lot of time. It's just one less thing you have to check. So if I checked this, that would give me 20 and 9. There's no way I'm going to combine that to an 8. Once again, I can't flip it because then there'd be common factors. This is where having a whiteboard is nice. I can't put 15 here. If I put it here, that's going to be way too big, so that's not working. So 4 and 3 is out. We tried all of our combos with it. Nothing worked, so let's try 6x, 2x. I'll throw in a 3 and a 5 and see if that works. Oh, wait, I can't do that, you crazy person, because 3 can't go there because that would be a common factor. So that saves me from having to check it. So what does that give me? 18 and 10. Okay, ooh, I'm feeling better about this. 18 and 10. I can combine those using opposite signs. If that's a negative, that means they're opposite signs. If I have negative 18 plus 10. So just make sure your signs are correct. And that should be your factor form. So 6x plus 5, 2x minus 3. If you have them in the other order, that's fine, as long as you have the same binomials. The thing with factoring, and I based it off of your teachers from last year, so I'm trying to do it the same way. If you randomly Google how to factor something, I can think of 10 ways off the top of my head. There's all these fancy methods, and there's kind of some weird stuff going on. So just be careful if you're a Googler, because it might show you different ways. So just as a heads up, I kind of stick to this way, because that's the way I've always done it. But there are some other fancy ways. Number 2, we have a difference of 2 squares. So that's usually semi-obvious because there's 2 terms. And for difference of 2 squares, we're basically going to use square roots to find our terms. The square root of x to the 4th is x squared. Basically, you're just taking that and splitting it up evenly. The square root of 81 is 9. We do 1 plus 1 minus. Something that is going to happen all the time, this section particularly, and later in the year as well, is you're factoring and you're like, yeah, I'm good, I factored it. Some things you can kind of keep going, and this is one of them, because this is also a difference of 2 squares, right? That's a perfect square, that's a perfect square, there's a minus in between. So I can actually keep factoring that. This I can't do anything to. If it's a plus, it just kind of sticks there. So that's actually your final answer. So I threw that one in there. 1, hopefully you recognize difference of 2 squares, but maybe you weren't used to kind of keep going. So we're going to say factor completely. That means once you're factored, you still have to check and see, can I keep going with my factor? So just as a heads up there, it's something that just pops up kind of randomly. So always just check your answer and say, is there anything else I can do? But that difference of 2 squares just is always popping up everywhere. So just be aware and keep a lookout. And when you think you got to a final answer, check, is there anything else I can do? And then number 3, there's a GCF. Always check for GCF. In this case, it is 2. They both have an x in common and they both have a y in common. Okay, so let's take that out and see what we get. If I divide this by 2xy, I'll be left with 9x, because the y's would cancel, right? If I divide this by 2xy, I'll be left with minus 5y. And then I'm always looking like, is there anything else I can do? And I feel like sometimes we just want to keep going. You think if you just do this, then that can't be it, but that really is just it. I just wanted to remind you, GCF means greatest common factor. That is factoring. So I feel like sometimes we tend to second guess ourselves, and you want to kind of keep doing stuff, but sometimes GCF is all you can do. So just as a heads up. Are there any questions on 1, 2, or 3, or anything that you guys saw last week? I'm going to go through those a little more just to see what mistakes people made, and kind of base some more problems off of that. But was there any specific questions that you guys had right now? Okay. So we are going to look at some new cases that maybe you haven't seen in the past, because these are going to be popping up this year. So we do a lot of stuff with factoring as we move forward. The whole next chapter is basically based around factoring. That's why we kind of do this stuff first. So this next thing is called factor by grouping. All right, let me find I have examples everywhere. Let me find my examples. So my problem is looking a little different. So it kind of is sticking out as like, I wouldn't even know what to do right now. Because I can factor trinomials and I can factor binomials when they're different to 2 squares, but 4 terms is looking a little funky. So we have this method called factor by grouping. So for factor by grouping, you're going to do exactly what it says. You're going to make 2 groups. So what I'm going to do is just use parentheses. I'm going to make this my first group, the first 2 terms, and then the second 2 terms I'll make another group. So now that I have my groups, I want to take the GCF out of each of them. So I'm just looking at the individual groups. For this first group, the GCF, what they have in common is just an A, right? So if I take out an A, I'm left with x minus 2y. The second group, I do the same exact step. I just look at the second group and I say, what is the GCF? The GCF over here, these both have a B in common. And when I divide out the B, I'll be left with x minus 2y. So hopefully you're noticing, hey, that was kind of magical, that this and this are the exact same thing. That should happen every single time. So every time you do factor by grouping, when you take the GCF out, these binomials should be the same. So just as a heads up, if they're not the same, you need to make them the same, or you just can't do it. So just a heads up. We're actually done, and we just need to write the answer. So I kind of like these, they're kind of quick. No really heavy lifting with them. So to write the final answer, these 2 GCFs that you just found, we're going to put in a binomial together. So we added A plus B. And then whatever that repeating binomial is, I'm going to write second. And that, my friends, is your answer. So main goal, 2 groups, GCF out of each. Make sure your binomials match. That has to happen for you to write the answer. But then from there, you just kind of write the answer. And that's that. I like factor by grouping. I feel like it's just like you do the same thing every time, and hopefully it kind of lines up nicely. All right, so let's look at one more, and then I'm going to have you guys try one. Let's do. So once again, 4 terms, that's kind of the hint that is factor by grouping. Once I see that, I'm going to make my 2 groups. So group 1, group 2. I'm going to take the GCF out of each. This first group has a GCF of 3A, so 2 things in common. I'll be left with B plus Y. The second group, they're both negative, so I'll take that out. Negative 2C. When I divide that out, I'll be left with B plus Y. Perfect. So you always know you're on the right track at this point when these 2 things match. That's kind of the key to these. And then the last thing is just to write the final answer. So those 2 outside GCFs are going to go together. And then whatever repeated, you're gonna write second. That'll be fun. So I'm gonna have you guys try one. So can you follow the steps for factor by grouping? Oh my gosh, papers everywhere. Sorry, I'm losing my mind here. Where did I get that? Oh. Okay, here it was. 6m minus 3 x. Okay, so if I said, hey, you just kind of went through the 2 problems, but the main goal, the steps are the same. Would you be able to try that 3rd one? So I'll give you a minute or 2. Okay, in a few seconds, we'll go over that one, see if you can follow the steps. Alright, so let's look and see how you're feeling. We're going to do one other new case called factoring using substitution. So that will be good. And then I'm going to give you a few minutes every day to kind of look at the packets, we'll kind of see like, oh, we should be able to do these ones. Maybe you have a few minutes to try them. Because the last thing I want is for you guys to go home Thursday, Friday and be like, I don't remember any of this. And, I'm going crazy here. So I'll try to give you a few minutes every day to kind of work for a little bit and see what questions are popping up. So when you are at home, there are no major issues, hopefully. So factor by grouping, 4 terms, make 2 groups. Okay. GCF of the first group is 3m. I'll be left with 2x minus w. Over here, I noticed they're both divisible by 2, and they both have an n in common. And what I noticed is my signs are opposite of what I need. So I need 2x minus w, and that's a negative and then a positive. So I'm going to make that a negative 2n when I take out the GCF, because I need to change my signs. And that would give me 2x minus w. So remember, these need to match exactly. You can't have opposite signs. Once that happens, I have everything I need. And I'm going to write my final answer, 3m minus 2n times 2x minus w. And that's your factor form. Are there any questions with factor by grouping or the steps we did to try those problems? Yes?
So when you do the factor by grouping and you first separate to the 2 groups.
Yeah.
And you put 2 parentheses next to each other, don't they multiply?
No, so if you think about what we're doing, we're backwards distributing. So think about doing this, right? If I were to distribute this out, I would do A times that and that, right? And then I would do B times that and that. That's all that's representing. It's just saying we're doing A times that, and then we're doing B times that.
Okay.
So you wouldn't have to do it twice. It's just the way we write it to organize
So when you
it.
in the first section, you're not changing the equation at all?
Where? Sorry.
Like the very first one, when you
Here?
first put it in the group.
No, yeah. No, it's just to group it. It's just more for us to organize the information than anything else. It's not for us to start multiplying it.
Okay.
It's just to separate them. But yeah, don't start multiplying things. That's where it gets a little funky. Nope, it's just more to group it for our liking. But yeah, don't start multiplying. We're trying to divide things out, not multiply things, so the heads up. All right, so let's look at our other new thing for today. We have some new stuff tomorrow too, but I was kind of trying to split it up evenly so we don't overload ourselves one day and then, I don't know, we're all a bit busy here. So this is called factoring by substitution. And then you will have a little bit of time to work at the end too to try some, but I'll just do the new stuff first. All right, let's find my problem here. How do I get that? Stuff everywhere. Where's my, oh, here it is. So that's a setup, and you're probably saying, oh, like, what's happening? Like, why is this happening? Usually there's just an x, now there's an x plus y. So now we're talking about binomials instead of monomials, and it's a big pain. The goal of factoring is the same. This looks kind of funky. So when I say factor by substitution, you don't have to do anything like fancy. What I do is off to the side, I'm just saying x plus y looks a little bit annoying. Instead of saying x plus y, I'm going to call it a. Ready? Here's what I do. I'm going to just say a squared plus 8. Anytime I see x plus y, I'm just replacing it with a minus 20. So I think we can all agree that this looks way nicer than that looks. It looks a little confusing with the binomials there. So what I did is I just, instead of writing that binomial, I just replaced it with something. I just replaced it with an a. You can use whatever. I can factor this, and I can factor it pretty easily. A squared is just a times a. 20 if I split it up. That would be 2 and 10, right? If I want to make 8 with opposite signs, that would be positive 10, negative 2. Okay, so that actually wasn't bad to factor. I'm almost done. So even though that x plus y was there, since I replaced it, it made it way easier to factor. All I have to do in the end is where I see a, I'm just going to put back in x plus y. So this is going to be x plus y minus 2, and that's going to be x plus y plus 10. And that's your factor form. I feel like it would have gotten kind of confusing if we just did it with that and tried to split that up. So I'm always like, I like to just replace it because I can factor that pretty easily, and then just to throw it back in the end isn't that bad. So it's just another way to think about, we already know how to factor. Can I just make this problem look easier to me? Yeah, I can. And then in the end, you just need to go back and replace it. So let's try another one where we're seeing like weird binomial stuff and things are looking a little funky. So let's say we have this one. Oh, like there's too much going on in my brain. So here's what I would do. I'm just going to pick A because I randomly picked that last period. You can pick any letter you please. But any time I see m minus n, I'm going to replace it with A. You can replace it with a symbol, a letter, whatever. It's just going to make it easier to, I don't know, take it. So I'm just going to say this is 3 a squared x squared minus, I'm just going to call that ax minus 2. So just in our minds, this is looking better than that. So maybe we're not as overwhelmed, freaking out as much. Our main goal now is just to factor this like normal. So 3 is just 1 and 3, right? A squared, we split up to a times a. X squared is an x and an x. So it's really just about splitting things between your two binomials. And what do we need? 2 is just 1 times 2. We need to make a negative 1 in the middle. So that would be, I'll put a 2 here, 1 here. Because that's 3ax. That's 2ax. And if I have -3 plus 2, that gives me -1. So, looks confusing, rewrite it, factor it like normal. Then at the end, once it's factored, go back and just anytime you see a, I'm gonna replace it with m minus n. Just be careful here because it's 3 and then it's m minus n times x. So you do want to put the m minus n in parentheses. Plus 2, so it's a little funky looking. And then that would be what, I'm just gonna write m minus n times x minus 1. So then you would just, in this case, you'd have to distribute the 3 in. So that would give you 3mx minus 3nx plus 2. And that would give me mx minus nx minus 1. Cool. So that, like, if I had to go from that to that, I'd be like, what the heck is happening? I don't know how to split that up. My brain just doesn't work that way. So substituting with something that's going to make it a little bit easier for you to comprehend, I highly suggest doing that. Makes life a little bit easier. So let's do one more, and then we'll do more of this tomorrow. So if you're like, oh, I feel like that's kind of a different way of thinking here. So let's do one more. Let's do this one. This one won't be as bad. So one more, and then I just want to quickly point out a few things in that packet. When I see the binomial thing, nope. So I'm going to say when I see x plus y, I'm going to replace it with a. So I'm going to say that's a squared plus 2a minus 24. Because this looks better. This doesn't freak me out. 2 parentheses. I split up my a squared, so that one's pretty easy. 24, 12, what do we got? 3 and 8. Oh, it's 4 and 6. Yeah, I could have done that from the beginning, you crazy lady. So if I have positive 6, negative 4. So I'm feeling pretty good about that. The only last thing I need to do once it's factored is when I see a, I just replace it with x plus y. And that's my final. So I know it's kind of a lot of new stuff. So for now, just do your best, write a few examples down. We'll have plenty of time tomorrow. We just have one other new thing to do, but then we'll have some time to practice. So just looking at that factoring packet soon, I know we don't really leave for 10 more minutes, but I just wanted to point a few things out to you. So this is your Thursday, Friday work. I know it's a lot of problems. I thought we'll do some together. We'll give it to you on a Monday. It's due on a Friday, so that does give you plenty of time. And I just want to make sure we can at least look at 1 or 2. So some of these are kind of basic, like numbers 1, 2, 3, you should be able to do pretty easily. Just as a heads up, number 4 is not in standard form. So if you ever see an equation, it does have to be in standard form. So that should be x squared minus 8x minus 20. So just little things to look out for. I just wanted to show you one like number 8. When things are a little different, I'd like to show it to you just because I don't want you sitting at home and be like, we never saw this. And I don't know, it's been a year. I don't know how to have to do this. So if I look at one like number 8, it says, oops, that's not what it says at all. Okay. It says a to the 2m plus, why should I write today? 6a to the m minus 16. Don't get too freaked out by this. I feel like the 2m, like, sends people up at the end. Just think about how you're taking that and splitting it between your parentheses. If you had your base of a, you would just do a to the m. Because when you multiply 2 things, you add their exponents. So that's a little reminder of properties of exponents. So technically a times m, a to the m times a to the m is a to the 2m because you add the exponents. If you're ever confused about how to split something up, just look at the middle term. That's what it should split to. So if that's a to the m, you should be a to the m. But other than that, the factoring is the same. 16, 2 and 8. So you would have a positive 8 and negative 2 to get your 6, and that's that. But I just didn't want that 2 up to freak people out. So there's a few other ones like that. So one of them, it's y to the 2x, so it would just be y to the x, y to the x. So little things like that. You're focusing on the coefficients. Please look out for GCS as well. You should be able to do a good amount of part 2 as well. Part 2 is GCF, factor by grouping, which we did at the beginning. And there's some difference of 2 square stuff in there. There's a few things I'll point out to you tomorrow. Some of the stuff with fractions, I'll show you a few things. But just as a heads up, part 3 is factor by substitution, which we will do more work on tomorrow. But if you ever just bored, I don't know, you can do that. And then the last thing is cubics. We'll talk about some of the difference of cubics tomorrow. And then we'll kind of just glance through and see if there's any you definitely want to go over before you leave. If you're ever stuck, feel free to just circle something. Even if you send me a quick email like, hey, in part 2, I have no idea how to do number 8. I can send you a quick little video. Like making those videos takes me 2 seconds, and it's way easier than me trying to write on email. But I don't mind doing that.